we find that the mean value theorem is tested more often than the other two theorems on the exam because it's getting into both the differentiability aspect and the continuity aspect. Now, they may or may not actually reference the phrase mean value theorem on the exam, but there are some clues to help us out. In example 26, we actually are referencing it. We're told that f of x is equal to x to the 1/3, and we're asked, does mean value theorem guarantee that the derivative is going to be equal to 1 on the interval from -1 to 1? Well, the mean value theorem says that the derivative will be equal to the average rate of change, something we learned way back in September, as long as two things are true. The first is that the function is continuous on the interval from the closed interval from a to b, and the second is that the function is differentiable on the open interval from a to b. Okay. So these two conditions have to be true. And if they are true, then we can do an average rate of change on the interval to see if, in fact, the average rate of change equals the value which they're asking about. Okay. Now, it turns out for part A that if we do an average rate of change with this function on this interval, we're going to get 1. But I'm going to skip that part right now because I want to go to the conditions because they love to test you on the conditions. Okay. Check out what's happening right here. We have the function, the cube root of x. All right, x to the 1/3 is the same thing as the cube root of x. Okay. The graph of the cube root of x, if you happen to recall, will go through these 3 points. Because the cube root of -1 is -1, the cube root of 0 is 0, and the cube root of 1 is 1. And otherwise, the function follows this type of curvature, more or less. Okay. Well, is this function continuous on the closed interval from -1 to 1, the interval that we're interested in? Here's -1. Here's 1. The function is absolutely continuous in between. There's no, my marker's on the board the whole time. So that's fine. The second condition says that the function has to be differentiable on the interval from a to b. Is that true? And the answer is no. Because we have, just for an instant, let me go to my red marker here, we have a vertical tangent line right here. And we know that one of the spots where a function is not differentiable is when the function has a vertical tangent line. All right, the derivative is the slope of the tangent line, and vertical lines have an undefined slope. So the derivative is undefined. So right there, at that one point, the function is not differentiable. And since the function is not differentiable, that means that the mean value theorem cuts off its guarantee. Both conditions have to be true in order for the mean value theorem to guarantee that the derivative will be equal to the average rate of change. The function is not differentiable right in the middle of the interval, so no. Okay. Even though if we quickly did f of 1 minus f of -1 over 1 minus -1, this would produce an answer of 1. Even though that's the case, it does not matter as far as the mean value theorem is concerned, because the second part of the condition was found to be false. However, let's look at part B. How about, actually, you know what, this should not be 1/8, this should be 1/7, my bad. Okay, is it true that the derivative will be equal to 1/7, as you see on your sheets there, sometime during the interval from x equals 1 to x equals 8? Okay, well, let's go back to our graph and our conditions. Our cube root, you see that it just pops right off the screen, just keeps on going. So we're interested from 1 all the way to, we'll call 8 right over there, which is barely on the board for you. Okay, that function is continuous during this entire time. Okay, the marker doesn't come off the board. In addition to that, the function is differentiable between 1 and 8. No discontinuities, no vertical tangent lines, no corners or cusps. We're good. So this will be true if the average rate of change happens to be equal to this value. Let's find the average rate of change. What happens when we plug 8 into our function? We have the cube root of 8. What number times itself again will be equal to 8? 2. So we have 2 minus the cube root of 1. Any root of 1 is going to be 1. So 2 minus 1 over 8 minus 1, which gives us 1 over 7. So the answer this time is going to be yes, because both conditions were met and the average rate of change turned out to be that value right there.